Welcome to today's demonstration of the latest release, 7.1, for Automic Continuous Delivery Director. Now, before we dive right into the product demonstration, I do want to provide a little context, especially since this month the State of DevOps report is out. Some things to observe, or what we're going to talk about real quickly, is the graphic here that compares elite performers from low performers. If we start along the top axis where we look at the throughput, we find that elite performers are able to deploy 208 times, not percentage, but times more frequently than low performers. And that for the lead time from commit to deploy or commit to release, elite performers are able to get or close that gap 106 times faster than low performers. That means the people who are organizations that have DevOps and the infrastructure and the apps that are supporting their DevOps culture and practices are able to respond to their customers' market demands far faster than those who aren't. Now, I remember meeting with an executive, and the executive was like, who cares if you can go fast if you can't do it safely, if you can't have control in it? Well, some interesting stats along that too with this year's report. Along the stability axis, the lower horizontal axis here, we find that when it comes to recovering from incidences, that elite performers are able to recover 2,600 times faster than low performers. That's amazingly fast, blindingly fast, blink of an eye fast. And also that the quality of what they push out is better, that they are they have a 7 times lower change rate to failure, 7 times lower change rate failure rate. So some significant things going on with DevOps. Now, another way to look at this, we look at the 4 performance metrics that the previous graph broke down in a comparison analysis. There are basically the 4. That is lead time to release, from a code commit to getting it out into the hands of a customer. You've got deployment frequency. You've then got your change fail rate and your time to respond or restore, remediate when something goes wrong. And one of the things the report talks about that ties or helps these 4 metrics is the availability of the service and infrastructure that these systems are dependent on. So these are just some background things that are going on with DevOps that we're finding happening with DevOps practices. Now, one of the key practices or behaviors of DevOps and DevOps cultures is the practice of continuous delivery. Indeed, since one of the core things of continuous delivery is automation, unless you have continuous delivery, you aren't able to really do all those neat things, 108 times, 2,600 times things that you saw, those fantastic stats, unless you have continuous delivery, unless you're able to automate the throughput. Now, when we talk about scaling this out, so that it is a sustainable practice and culture throughout the enterprise, there are some challenges that get in the way. And indeed, even with DevOps, even with these great numbers, it turns out that your big constraint in pushing out the changes and trying to make sure you're pushing out high quality changes is testing them, making sure that you have a high quality deployment that's going out the door. And when you scale this out to an enterprise side, we have found with our customers that there are 2 key or core problems that tend to occur that enterprises struggle with, which is ensuring that the quality of what they send out is actually of a significant quality, of significant code coverage, and that they can reduce the bottlenecks that exist within testing and itself, the QA processes. And so what I want to walk you through is what Automic Continuous Delivery Director 7.1 does to address these issues. So one of the things that we're doing is we're using our ML algorithms to help DevOps teams be more productive and improve the releases, right? Do more than what the DevOps metrics are showing now. We want to take the elite performers to make them ultra elite. There are 4 things that our algorithms and our pipeline mechanics are going to help organizations do. We're going to help them reduce their test cycle times, help them find defects earlier where they're cheaper to be fixed and they're faster to fix when you find them earlier, identify the gaps and understand the risks in your test planning. What is your core coverage, your test coverage, and then of course accelerate that feedback to developers. Right? We want to, anytime there's a failure, we want that feedback to get back to developers ASAP. And it's well known, you all know this when it comes to DevOps, the longer you wait or it takes for feedback to come to development, the further their minds are away from the code changes that they've made. So we want to accelerate that feedback back to development. Now, we do this several ways. One of the things that we do, if we look at all the test suites that are available, what Continuous Delivery Director does is it takes all the test things and it correlates all the changes that are being made, and it intelligently selects the appropriate subtests of the tasks. This way, you're in a position to run the right tests with the right code changes. So for example, if I change a particular class in my application, there isn't technically a need to run every single test of all my test suites. There just isn't. If I've just changed one little thing, and indeed from an agile DevOps continuous delivery best practice, we want to make very small changes. So what we want to do is really fine tune the testing that goes on so that as I make a small change, I'm able to quantify or get the quality test with that change. And so this is exactly what Continuous Delivery Director does, is it makes that intelligent selected subset so that you have high confidence. And one of the things that we do, and you'll see in the demonstration, is that we're tracking several things. We will track, for example, flaky tests, so that flaky tests run quick. They run first. We will prioritize those to run first so that should they fail, the feedback goes back to development very quickly rather than waiting to push those things off to the end. We're going to make sure that if you've updated or created a new test case, those also run first. If you manually mark any of these tests as a must run or very important run, we'll do those. There's a whole level of variables that go into our algorithm in helping to prioritize the test and selecting the tests that are going to run, and you're going to see that in our demonstration. And so one of the things to put a visual to this, if you're making code changes, what we actually do is we map the test suites to the files that the test suite changes. Therefore, that's kind of the magic here. So when I change a class, a component of an application, then I am actually going to make sure and prioritize only the tests that touch that thing, rather than using a scattergun approach where I'm just, throw everything at the wall and see what sticks. I am being very targeted in making sure that the specific code changes I made and the changes that those tests touch, or that rather the ancillary dependent things that the code change I made touch, are going to be tested as well. And so you can have high confidence that what you're releasing is being is of a high quality, and we're reducing the test cycle time. So not only can developers code and do small, we're helping the test organization, the QA, to be far more agile as well, because now we're actually able to run their test in as short a time as possible, while also reaching that great equilibrium of ensuring that the right tests are run at the right time. So let's go ahead and jump right into the product here, and let me walk you right through the product demonstration. As you can see, we got our test case listed here. I got some Gradle test, JUnit test based on Gradle. I got robot test, which will test our APIs, just to have a couple of different frameworks listed here. But let's talk about the use case, okay? So let's jump into our releases. Here are some of the releases I have defined. And I'm going to jump right into the release pipeline. Let me stop this here for a minute, okay? So here's my release pipeline for this application. I have 3 different pipelines, as you see, but we're going to focus on the dev phase of our pipeline, all right, if that's all right. So let's go ahead and jump into our use case here, shall we? So I'm going to bring up GitHub, This is my repository for the source code. This is what a developer would do. And we're going to come in here, and what we want to do is make a change. Okay? So this is our simple banking app, and we want to add a new feature. So I'm going to navigate through my application here. Let's go down to my library. I'm going to click in here. And what I want to do in this case is I want to add some new capabilities here. And the idea is that we want to extend our login credentials capability to where we can include a GitHub login. And the GitHub login will act as a single sign-on into my application. All right? So let's go ahead and get ready to make this change. All right, so let's go down to the actual code file. Here's the actual source code. And I'm going to come down here to the bottom, and I'm going to add a new class. You can see some of the other classes. As I mentioned before, I just want to extend the login capabilities of my application. I already have a single sign-on for LinkedIn, and obviously all the sites work the same. Central authority entities, Google, LinkedIn, Facebook, what have you. So what I want to do right here is add one, as I mentioned before, for GitHub. And this change, I'm just going to duplicate one of these files, one of the lines here. And as you're probably familiar, it just is going to ask the user to log in at that other site, and then the credential token gets passed over to me. So let me go ahead and make the appropriate change to my source code. Like I said, for example purposes, this is a simple change. All right, get this from LinkedIn to GitHub. Okay, so now I've just typed GitHub. Okay, and let's make sure it's okay. Make sure I didn't miss anything. Okay, so let's go ahead and click commit. So now I've committed a change to my code, and it's small for example purposes, but you'll get the idea. The key thing to realize is I've changed this URL here, but it's for a single class. That's all I've actually done. Now what I want to do is also include the test. I want to add a test that's going to this. I obviously want to make sure that the GitHub login will work as I've changed it. So let's go here to my repository where all my tests are, and I want to go ahead and add a new test. So I want to upload it. So as you can see, I have lots of other tests that are listed here that can run within Continuous Delivery Director. And I've already got my login to Google, login to LinkedIn, and I want to add a new test that's going to test logging in to log into GitHub. I'm going to go ahead and upload my test to GitHub, commit the change. Now it's in my repository. So what next I need to do is I need to run a build. And just to restate, of course, I've uploaded a test, and I've uploaded some change to my actual code, and we're going to show you how Automic Continuous Delivery Director will recognize those changes. So let's go ahead and make a switch to Jenkins, and we're going to go ahead and run our build. We're going to look at our project first, and let's go ahead and click build. And it's going to go ahead and do its thing. Now we've got build 180. That's our active build that was created. So while that gets started, let's switch to Continuous Delivery Director. Now, again, just to restate, our main release is composed of 3 smaller apps or sub-apps. And we made a change to the online banking application. And so what we're going to see here when the build is done is we're going to execute the test cases that are run. So we're going to be able to see how the tests are orchestrated intelligently by Continuous Delivery Director to only run the specific tests based on the specific changes. So you can already see we've got build 180 that's underway, and then we can come down here and take a look at the test cycle that's executing. And so now we actually know that Automic Continuous Delivery Director is executing and intelligently figuring out what tests need to run and prioritizing them, right? Because traditionally, everyone runs every test all the time. But if you're doing agile practices, if you're trying to really do DevOps, and you just don't have necessarily time to run all the tests, especially with when you got a lot of changes going on. So if we hover over here, for example, you can see we have 8 tests that are running. If you remember beforehand, we had 26 tests that we could have run, and we intelligently selected the 8. So what Automic Continuous Delivery Director is doing for you is allowing you to run only the right tests at the right time. Now, of course, the big question is, wait a minute, how is that happening? How can I have confidence that Continuous Delivery Director is, in fact, doing the right test, so I have the correct code coverage for my test? For example, if I change one class, as I demonstrated for you, how do I have the confidence that we're running just the most relevant or important tests associated with that single code change? So what we're going to do is we're going to go back to those 26 tests, and we're going to start the narrative there. First thing you notice is that there are 27 tests. If you recall, when I started this demonstration, we had 26 tests, but we uploaded to GitHub another test, and you can see that Automic Continuous Delivery Director automatically recognized that there was an additional test that had to be thrown into its list of consideration, where we run our ML algorithms to figure out what tests ought to actually run as part of the test suite with my code commit. Okay, so now the other thing I want you to take a look at is the columns, and we're going to look at some of the criteria as we scroll down here. So the first thing to recognize is that we have a test here. You as a user, a QA person, or someone within the release, even a developer, you can flag tests that state that have to run. No matter what, you can flag tests that must run under any and all cases. So that's an important use case or important feature to recognize. Okay, so aside from all the intelligence that we have built into the product and trying to figure out which test ought to run or which test are the most important or relevant to run, you do have full control over which tests are going to run, and you can actually earmark these tests as they have to run no matter what test to run. But the key is we're giving you the capability here with the flexibility, right? So that you are not bound to have to run everything on the scattergun approach. Now, if we scroll down here a little bit, you can see under the flaky column, we've got some tests that are marked as flaky. Now, this is something that you, the user, would not do. This is something we have done for you. And we have identified tests that tend to provide inconsistent results based on historical data. So using heuristics, we're able to recommend tests that are flaky, and we want these to run early on in a test cycle, so that if they fail, they're going to fail very quickly. We can get that feedback back to developers. So we want to shorten that fail fast thing in the testing phase of our continuous delivery pipeline. So let's go back to our release here, and let's take a look at our release. All right, so at this point, our tests are complete, and you can see we have a failure. And if we hover over this, we can actually see that of the 8 tests of the 27 that we had, we ran 8, and 1 of the 8 failed. We ran 6 Gradle tests and 2 of our API robot framework tests, and 1 of the Gradle tests are the thing that actually failed. Now what we want to do is go ahead and drill down into this and look at some of the details specific to the test. So here's the list of tests that we saw. We looked at the screen before, and you can see the list of tests that run. As I already stated, we had a total of 27, but Automic Continuous Delivery Director whittled that down intelligently that we need to run these specific tests, 8 tests that are related to the code change that had been made and to, of course, the change in the test cases that we had selected. So we automatically made the determination that these are the more relevant tests that needed to run. So if you go ahead and take a look here, we have the login with Google, we have the login with LinkedIn. We didn't make a change there, but the system figured out that, yeah, but you've changed the login functionality for the app, so therefore these tests are in fact relevant. Now you also see that, of course, we have our login with GitHub test. This is the actual change we did make, and so it's recognizing that as well, and it's editing it up. Now there are a few other tests that were selected. So for example, you can see security tests were selected, but this is because we had marked this test as mandatory, as in must run. So that was included there. And we also have contact support. Now this test was marked as flaky on the previous screen, and it fails very often. And of course we ran it first, as it's prioritized here in the list. And of course it failed. And this is why we wanted to run it. And we can drill in here very quickly and see some additional details of this. Now, what we want to do, of course, is drill into this even further and do a little bit of the root cause analysis as to why this particular test might have failed. The name of the test is called Test Contact. And let's go ahead and drill into this. Now, what we can see here is a report, and it provides us the details for this particular test run. And what I can then, of course, use these details here, all this information, is try to do some root cause analysis on why the test failed. This is particularly useful, of course, for flaky tests, but we want to use those kind of things for our next tech cycle. Okay, so let's go ahead and switch to something else at this moment. So here we can see our release quality by application dashboard, and we're going to focus a little more on the test distribution. There are some other stats here like the number of builds and so forth, time saved, etc. But let's look at the build. So look at each build and the test runs that have occurred with each build. And what we want to do is we're just going to look at our top one, right? Because this is the one that we just did. This is build 180. Here we see that there were 8 that were actually selected, 8 tests, and 1 failed. All right? And the reason why this test was selected was because it was a flaky test, right? Now, there were 19 tests that, of course, did not run, and the reason, of course, they didn't run is because they weren't really correlated to the changes that had come in here. Now you have complete control over this. You can state that all tests should run all the time, and indeed that could have happened. We could have run all 27 tests. But if you allow us to, we can use our ML algorithm and use heuristics to determine what are the most relevant tests. So you're getting the right test to run at the right time. Thus, you're shortening the amount of time that is being spent in each test run and the amount of shortening the feedback loop to development. The last thing you want to do, of course, is get back to development when things are taking too long. I mean, or rather, you don't want to save your flaky test to the very end, because you want to get the feedback back to development as quickly as possible if there's inconsistency occurring in the application behavior. Okay, so let's dive into this a little more. We've got build 150 here. You see all the other builds that are here. They all have different test numbers that have run. Indeed, they're all different. And this is because, like the build 150 that I have run you through, they too have all run and used our intelligence to figure out which test ought to run. Now, if we hover over our build right here, we can get a breakdown as to why we ran the specific test that we did. So this should actually help provide you with a great deal of confidence. So there were 8 tests selected, 1 was failed, 19 were not selected, right? We already covered that. But here we can see what their test results are. We can see the breakdown. And you can see we got 1 6 Gradle test, 2 robot tests, and then visually we can see the breakdown of why the tests were actually selected. So 5 test suites were relevant, meaning they matched the code changes and they matched the mandatory test criteria that you had tagged or flagged. So in this case, that means we ran all the login type tests that were associated with the login change that we made, the Google, the LinkedIn, and so forth, as well as the GitHub one that we added. So you can also see right here the name of the test. And then if we go over here, we can see the 3 tests that were executed because they were flaky. So if you remember back when we showed this before earlier in the demo, there was 1 that had failed, and 2 of the flaky tests actually succeeded, but 1 actually had failed. And so I can graphically see this, and we're not just looking at any test, we're breaking down why we ran things. And then of course here we have one of the tests that were marked as must run, right? The user had marked this as saying I have to run it. So very easily and very quickly we get a breakdown of what ran and why. And here you can of course see what the overlap is. There are some overlaps between perhaps flaky tests, tests that you mark as relevant, and what corresponds to the code changes that were made. So you actually have a great visualization of what the test coverage is for any code change that you make. So what's important to see here is that you can look at the size of the circles and very quickly see the number of tests that were run as a whole for this test run, and they're all relation to each other, right? So for example, if I saw the flaky test that I'm hovering over here was really big, this would indicate that there's a huge problem, or that I have a big problem, and that's not a good thing, of course, at all. I have a big quality issue right with the test. So in summary, what Automic Continuous Delivery Director can do for your organization is reduce your cycle times, find defects earlier, identify the gaps and risks in your test plan, and accelerate the feedback loops to developers. In the end, we're hoping to make those great DevOps elite performers ultra elite. We use ML and heuristics to intelligently select the right tests that they run at the right time. Hopefully that was obvious to you. There's a whole lot more, and if you're interested in seeing additional demonstration and so forth, those arrangements can be made. And speaking of learning more and understanding more, some great things for you. You can actually use Automic Continuous Delivery for free. All you got to do is simply go to cddirector.io, click the free starter edition button, and you can use Continuous Delivery Director to your heart's content. You will get 10 active releases that are included with the freemium version of Continuous Delivery Director. And if you're interested in learning more about what we are offering the market as a whole, you can take a look at our BizOps Starter Edition. Now, Automic Continuous Delivery Director is part of the BizOps Starter Edition, but there are other ancillary tools as well, such as Rally and BlazeMeter, that also are offering freemium capabilities. And if you want to learn more about that and actually use those products for free as well, just click the link here, broadcom.com/bizops-starter-edition, and you can get started with just not what I'm showing you, but actually get yourself to the entire continuous delivery pipeline suite of solutions. And with that, I would just love to thank you for your time and hope you have a great day.